Welcome, everyone. Good to see some of you from a few minutes ago and some new faces. So we'll be doing a little bit of a deeper dive into the generator owner and generator operator standards and associated requirements. The fun stuff. We'll do a quick review of just how GO versus GOP functions and applicability standards broken out, but I'll skim right over it because we covered it in the NERC 101 session a few minutes ago, and then dive into standards applicable to generator owners, then generator operators, and then talk a little bit about kind of pre-registration and timelines overall for getting your compliance programs ready and registering with NERC. I'm going to skip over myself to spare everyone who is here for the last session, but I'm John Franzino, happy to be here. And again, skimming over this, if you want more detail, more color around generator operator versus generator owner, you can go back and review the NERC 101 session we did a few minutes ago. But there are a lot of standards and requirements to cover in this hour and a half, so I am going to just fly through these, but leave them as kind of leave behinds or go review the NERC 101 deck we just covered. We will be in this presentation focusing on the 693 or operations and planning standards. And then this afternoon, we'll be covering the SIP standards in depth, but no real discussion on SIP during this session. All right, let's get into the fun stuff. Generator owners. So here's a high-level view of the different reliability standard families and associated standards that are applicable to generator owners. As we discussed in the NERC 101 session, applicability is primarily derived and driven by your functional registration. So this is for the generator owner registration. However, there are some additional carve-outs for applicability, like one we'll talk about is on the vegetation management program. Not every generator owner, an associated generator, has to have a vegetation management program. It has to do with the type of gen tie you have. So that'll come into play for some of the standards. All right, we're just going to kind of start down the list, more or less. I will just caveat, we are not going to cover every single standard that is in this table here, just in the essence of time. They only gave me 90 minutes, and nobody wants to hear me talk for more than 90 minutes consecutively anyway. So we're going to skip over a few, but really hit the primary, most important ones for generator owners and generator operators. As Sarah said, if you have any questions throughout, throw them in chat, or if we don't go into depth on one of the standard families or requirements that you have a question on, still feel free to ask the question, or we can follow up after the fact. All right, so first up on the list, we're going to cover emergency operations EOP 4, which is event reporting. So we're going to get into the event types, but essentially just at the basic boring requirement level, you have to have an event reporting operating plan put in place for the facility. I will say that this is one of the standards that is applicable to both the generator owner and generator operator. I'll be covering it here in the generator owner section and skipping over it when we get to generator operator, just because the requirement, the plan, it's all the same. Obviously, when we're talking about applicability to the GO, generator owner, that is associated with the actual generating facility, and if any event that meets the reporting threshold happens there, and the applicability for the generator operator is associated with the control center and that facility if any event happens there. But otherwise, really the same requirement to have that plan and understand the threshold for reporting and be able to report that to the necessary entities. So you have to have the plan in R1, and then you have to report events that meet the reporting threshold no later than 24 hours after identifying that the event met the threshold. So what kind of events are we talking about? We're primarily talking about physical or cybersecurity related events that impact the facility's operation. So Any damage or destruction, again, both in the realm of physical and cyber, from an actual or suspected intentional human action. So obviously, what, year or 2 years ago, we had all those events in Moore County, North Carolina, with substations being shot. That would definitely meet an EOP4 reporting threshold. Conversely, unfortunately, there's because of these IBR facilities specifically, but this applies to traditional generators as well. There's theft that happens, right? Copper theft, otherwise, and other things at the facility. If you have a break-in and there was theft, that's an unfortunate day, of course. But unless that event resulted in, the degradation of operations of the facility, that doesn't meet the EOP4 reporting requirements. One thing to note is that, again, because this standard is both applicable to a GO and GOP, you definitely want to make sure there's coordination between the two entities, because we don't want to double report on the same event. So ensure that we understand, depending on where the event occurs, whether it's at the generator or the control center, and the type of event impact, that there's coordination between the GO and GOP about who's leading reporting for that event if it does meet the reporting threshold. So we're talking about NERC reliability standards, but this is one area where we will also offshoot and deviate to a outside of NERC requirement, the DOE OE 417 report. So parallel to NERC, there is the OE 417 reporting requirements, which are very similar yet slightly different. And for better or for worse, especially on the cybersecurity side of the house, these types of differences in reporting requirements is becoming very challenging and cumbersome. But that's a different discussion for this afternoon. Simply put, if you have an event that meets the EOP4 reporting criteria, you definitely should also submit the OE 417 report, and usually vice versa as well. So we always recommend entities that you kind of look at these two things in tandem, submit them in parallel. But you are reporting to two different regulatory bodies when you do that. When EOP4, you're reporting to the NERC EISAC, and the OE 417 process goes to the DOE. As you can see on top of the EOP4 reporting form on the left there, you don't need to necessarily fill out the two separate reports, as the NERC EISAC will just accept the OE 417 report as well. So you don't need to do double work in terms of documenting the event, but you do need to make sure that you're reporting through both channels, on the NERC EISAC side under EOP4, as well as to the DOE under OE 417. We won't get too in depth on all this, but one of the differences between OE 417 and EOP4 is just the timeline for reporting for different events. So keep an eye on that. Overall, the OE 417 has some tighter timelines in terms of notification of the report than the EOP4 requirements. And I would just make a general statement here that whenever we're talking about reporting potential or suspected incidents, whether on the physical security side or the cybersecurity side, especially when we're at the initial report stage, the expectation is not that you have all the details, a root cause analysis, anything like that. Definitely lean on the side of, if you're questioning whether or not an event meets the reporting threshold, go ahead and report it. To that point, again, we'll touch on this afternoon in more depth, but like the NERC EISAC, they are set, even though NERC's in the name and they are technically part of NERC, they operate separately. So they are not a regulatory or compliance enforcement body. They are there to gather industry intelligence, look at physical and cybersecurity risks and trends across the bulk electric system. But the punchline being that if you have a question, you're not sure, err on the side of reporting. They're not there to get you in trouble. They're there to support you. Pick up the phone, call them, ask them, hey, this is the situation. Is this something you guys want a formal report on? They are there to help the industry with threat analysis and threat intelligence, not to enforce compliance. All right, we're going to switch topics to a newer hot button topic, the extreme cold weather preparedness and operations requirements. As I mentioned in the NERC 101 training, where do we come up with these different reliability standards and requirements? Well, 9 times out of 10, it's because a real event has already occurred on the grid, and we realized we did not manage a particular risk to the degree we think is acceptable to uphold reliability of the system. Extreme cold weather preparedness is obviously no different. Lots of events in Texas, particularly over the last handful of years, that have led to a heightened scrutiny and rigor around cold weather preparedness plans. So regardless of the location, somewhat like we'll talk about the vegetation management plan here shortly, you still need to have a plan, even if you're not in a cold weather area. Your plan may wind up being relatively simple, but again, that's why we had those events in Texas. They did not engineer those facilities for the type of cold weather that we actually had in the region. It was not part of the engineering design criteria, and thus we had critical failures. So that's where a cold weather preparedness plan steps in, is to manage, the 1 in 100 year cold weather event and make sure that we do not suffer reliability issues when that weather occurs. One thing I will touch on, we're not going to go in depth on the exact, what does a plan look like? We just don't have time for that today, but obviously something that the GridSecurity can support. I will say you have to train on the plan as well. So not only just have the plan, but you have to make sure that the appropriate personnel are trained on the necessary maintenance and response activities. All right, fact 3, vegetation management. So this is one of those standards that, while applicable to generator owners, overall, in this 4.3.1 applicability section here, you'll see that there is a specific criteria that a generator owner needs to meet in order for this standard to be applicable to them. And in simple terms, these are gen ties that, if you have a gen tie that is you don't have clear line of sight and it's greater than 1 mile, and it's 200 kV or higher, then that ropes you into needing a vegetation management program. Vegetation management, again, is another area where we have experienced many reliability events related to vegetation management issues. So we know we get this question a lot. Well, my facility's in the desert, there's no vegetation, but I do have a gen tie more than 1 mile. It doesn't have clear line of sight. Maybe it does some twists and turns, etc. Do I really need a vegetation management program? The answer is yes. That program, obviously doesn't maybe result in vegetation maintenance because there is no vegetation to trim and prune. However, you still need out of the program to periodically inspect and ensure that vegetation will not encroach your right of way and risk contacting the conductors on the gen tie. Moving on to another facility standard, in fact 8, and this is about facility rating. So remember talking about really one of the primary roles and responsibilities of a generator owner is kind of on that design and engineering side. So when building the facility, we need to ensure we understand all the different current carrying elements and what their rating is from an electrical, standpoint, voltage, amperage, etc. And really the punchline then becomes, how do we determine and identify the most limiting element? So here's a real simple example, but this process, first needs to start during the construction and commissioning phase of a project. And again, it's an inventorying of all current carrying elements. Anything that electrons will flow over, starting from the actual, solar facility, starting actually from the modules itself, all the way up to the point of interconnection with the off-taking utility. And that has to be well documented. You must have a methodology for how you're determining and calculating the facility rating. And again, you have to identify the most limiting element. One thing to note is that this needs to be maintained throughout the life cycle of a project. So, essentially it's the same thing with all of these requirements and standards, but as maintenance or replacements occur at a facility over its life cycle, it is an easy thing to potentially forget about and miss if you do not replace a piece of current carrying equipment with an exact like for like piece of equipment, and it changes, has different voltage or amperage ratings. You need to update your facility rating documentation and associated evidence to ensure that you didn't change your most limiting element. And you must be ready to provide the ratings upon request from one of the other reliability entities, and also have that again upon any changes, have that ready upon any changes to your facility rating. Moving on to modeling, another hot button one in terms of why the push to really get more IBRs registered. And again, we touched on that earlier, and Kaylee and Ben will do a deeper dive later this afternoon. But one of the risks and issues identified with IBRs is that, and really a lot of generation in general, is that maybe our models aren't accurate enough. And so the whole goal of the modeling family of standards, and you can see there's 4 of them that are applicable to generator owners, is to ensure that the transmission operators, the balancing authorities, and even the RCs have an accurate enough model of how your facility is going to perform under normal operating conditions, as well as when there are system disturbances, because they are modeling their entire system. So they are studying contingencies, and when we have outages and when we have a frequency event, how is the collective system going to respond, and ensuring we have accurate models on a per generator basis is the input to ensuring we have an accurate enough model of the entire system. Mod 32 is mostly addressed during the work that happens in the interconnection phase of a project. You need to make sure that your T's are crossed and I's are dotted from a NERC Mod 32 standpoint, but usually you don't have to do any quote unquote additional work, just ensuring that there were no material modifications between the interconnection process and now when the facility is going to commercial operations, versus a little bit different than Mod 25, 26, and 27. Those are actual tests, real tests that need to be done once the facility is far enough along during the commissioning process, or within a certain time frame after commercial operations. So Mod 25 is the verification of real and reactive power capability. And this one needs to be done within 1 year of commercial operations, and then again every 5 years thereafter. Mod 25 is kind of, for lack of a better term, the simpler of the modeling verification tests when compared to 26 and 27. Mod 25, doesn't usually require any modifications to power plant controller logic or anything like that. Really, usually the challenging part about Mod 25, if anything, is when we're talking about solar or wind and inverter-based resources, is finding the right window of time with the right weather conditions to perform the test, and authorization from the TOP to perform the test. But beyond that, pretty simple test, just maxing out real and reactive power capabilities of the facility, and to again verify that the models that the transmission operators, transmission planners, et cetera, have are accurate enough about how the facility actually performs in real life. 26 is about volt and VAR controls. So essentially seeing how the plant will respond when there is a voltage deviation on the system. And this is where, modifying plant controller inputs and control logic comes into play, because you can't always just wait for an actual system disturbance to happen, right? Because one, we need to do this within a year of COD, and two, if you're going to be doing a system, trying to use a real system disturbance, even if it happens within the first year of operations, you need other measurement techniques that aren't always there to say that, yeah, this is what happened on the system and here's how it responded. So most of the time, 26 and 27, you were scheduling a test to be explicitly done, and you were, for lack of a better term, tricking the power plant controller into thinking that there was a voltage event or excursion, a disturbance on the system, and then recording high-speed data on how the plant responded to that voltage excursion. And then same exact concept on Mod 27, except now we're looking at frequency events instead of voltage events. All right, shifting gears out of the modeling world into PRC, the protection system world. So PRC 4 is the misoperations requirement. And so generator owners need to, and what this is trying to do is to make sure that when a protection system element operates, right, a relay trips, that that relay and that element operated as intended, and it is not misconfigured or there's some other defect, right? Because protection systems are there to protect the generator or the elements of the system, but we don't want them to trip too early, right? Which maybe results in a grid reliability issue where we're actually exacerbating the disturbance on the system rather than supporting, or vice versa, not tripping at all and then risking, plant damage and safety issues. So anytime a protection system element operates at a facility, that operation needs to be analyzed to determine the root cause. And we need to have a process in place to make the call and determination on whether that element operated as intended, or was this a misoperation for one reason or another. So you have 120 days following a protection system operation to identify whether or not it was a quote unquote misoperation. You have to notify associated parties about that within 120 days as well. And then if you do determine that it was in fact a misoperation, then there needs to be a corrective action plan put in place within 60 days of identifying that the operation was a misoperation. That plan needs to be implemented and updated as necessary, essentially like any other good mitigation or corrective action plan should be. So yeah, disclaimer, really, this disclaimer at the bottom should be on all of this. These are summaries. We don't have enough time, and I don't want to put everyone to sleep going through the exact wording and intricate details of everything, but really just covering the concept level here. So in practice, PRC 4 usually requires a joint effort between the GOP and the GO. So this is a GO requirement. However, since the control center, the GOP is performing your real-time monitoring and operating the facility, and also oftentimes in the IBR world, they're also providing boots on the ground field services. This is one of the many GO requirements in which the GOP and GO need to work together in practice. So typically, the GOP is going to be the first to identify that a protection system element operated. And they're going to have hopefully some supporting details around that event and operator logs and data that they're gathering from the facility. And then typically, but not always, it depends on how contracts and O&M agreements are set up and whatnot. But then typically it's going to be the GO's responsibility to actually conduct that investigation on the protection system operation, and then eventually make the call and decision on whether or not it was a misoperation. And then, if it is a misoperation, again, we're going to be leading into then the corrective action plan that needs to be documented and carried out within 60 days of identifying that a misoperation occurred. All right, moving on to the next PRC standard applicable to GOs, which is PRC 5, and that's the Protection System Maintenance Program. So this is all about ensuring that all protection system elements are properly maintained over the life cycle of the facility. Most facilities have, somewhere between 90 and 100% of blue boxes, SELs for their protection system. And so we'll get into some of the details here regarding the maintenance intervals and what needs to happen. As I mentioned a second ago, this is another area in which it is a generator owner requirement. They own the compliance liability and responsibility. However, since the O&M GOP is also providing boots on the ground more times than not, the O&M is going to be the one carrying out this maintenance. So responsibility of the owner to put the program in place, to oversee the program and gather evidence from the O&M provider who's actually carrying out the activities on site. And similar to the misoperations requirement we just went over, if there are maintenance issues identified, they don't call it a corrective action plan in this standard. They call it an unresolved maintenance issue, but that requires follow-up and triaging to completion as well. So we're going to go through one of the many different tables of examples of the type of protection system element in which maintenance and testing requirements are applicable. But just here's a quick cheat sheet of the different verbiage used throughout these tables. So here we're just looking at a vented lead acid battery example. So the DC power supply for the protection system, typically speaking. The reason I use this as an example is because of all the different protection system elements and their associated maintenance requirements under PRC 5, the DC battery supply has the shortest time horizon for maintenance, aka the most frequent recurring maintenance required. So you can see that, for this battery type, and there's other battery types covered, but this is most common, you're looking at a 4-month interval to at least do some basic verifications and inspections of the battery system to ensure that it's working as intended. And, if you lose station service, et cetera, and really just so that the batteries can power the protection system elements to operate if they need to in an event. So most O&M providers are really accustomed to doing this already. There'll be a standard checklist, maintenance work order that usually quarterly, so every 3 months, so that you have a month buffer. You're going through and conducting this periodic verification and inspection of the battery system and documenting that and submitting that evidence to the generator owner's compliance team for filing that in the evidence repository to demonstrate compliance with PRC over the registration lifetime of the facility. We won't get into all the technical details, but again, there's probably, 30 pages of these tables for different types of protection system elements and their associated maintenance requirements and time horizons. Thankfully, since most relays these days are solid state relays, that their time horizons are either 6 to 12 years. So while you definitely want to conduct and document, your PRC maintenance at time zero, aka commissioning leading into commercial operations to kind of set that first date of maintenance. Besides batteries in a modern substation, you're not having to do these verifications and these maintenance activities all that frequently. Again, we're talking batteries on a quarterly basis, and then thereafter, I want to say off the top of the head, the next most frequent time horizon is every 6 years. So good that you don't have to do much besides batteries every year. Bad because since the time horizon is so long, it's one of those things that's easy to forget about. So you got to make sure you have the right program in place to track this over long duration and ensure that the required maintenance does get done at year 6 or at year 12, whatever it may be. All right, moving on probably to the hottest topic of all reliability standards as it relates to inverter-based resources. And that's PRC 24, which covers the frequency and voltage ride-through settings, as it's known. So again, I mentioned it a few minutes ago, but this standard is in place to ensure that generator owners are not setting their protection systems so conservatively to protect their own equipment that they're degrading the overall reliability of the system, right? So we're trying to find the happy middle ground, right? Obviously, NERC or no one else wants the actual equipment to be damaged in a grid event, right? Which is why we have protection systems, more or less. But at the same time, we can't all be too selfish and aka set them too conservatively that when we have the smallest of grid events, everyone's tripping offline because that just exacerbates the event. So again, PRC 24 covers both voltage and frequency ride-through requirements. We're looking at the voltage ride-through curve here. In the middle there is the no trip zone. So that is the bare minimum criteria for ensuring that the facility's protection system will ride through that event. What has happened in practice, especially with the advent of IBRs in recent years, is that many people have looked at this, those step curves as where they should set their protection system settings. But as you can see, this is a snippet from one of the many grid disturbance reports that we touched on in NERC 101 session related to IBRs and events that have been either caused or exacerbated by inverter-based resources. It is not we should not be setting that as the design requirement. This is the minimum requirement. And there are changes coming. PRC 29 is coming out to better address the same topic, but specifically for the IBR technology. But real punchline here is that you should set as wide of a no trip zone for your protection systems and inverters, et cetera, as possible. Of course, not so that they suffer damage in an event, but set it as wide as possible because that supports the overall reliability of the grid and keeps the generator online through a grid disturbance and grid event. The other, and I won't get into too much detail right now, but the other thing that's occurring as it relates to IBRs and voltage and frequency ride-through requirements is the concept of momentary cessation in the inverters. So it's, again, one of many different areas in which this new inverter technology doesn't really fit within the box or within the words as we've written previous regulatory constructs and reliability standards. So, because we've had real reliability events over the last, 5+ years related to IBRs, it's come to light that there's this nice little feature, so to speak, in momentary cessation, which again is really exacerbating the issue and how we're seeing these types of facilities perform when there is a grid disturbance event. So changes are coming here as well. Switching gears for a minute to VAR 2, which is probably, if I had to guess, one of the most, if not the most violated GOP requirement, especially for IBRs. And we're talking in the generator owner realm now. We'll talk a little bit more in the GOP section. And sorry, my comment on the most violated was really for GOPs. For GOs, it's a little simpler of a requirement in R5, and that's if you do change tap settings, right, for whether it's it's for seasonal voltage schedules or whatever else, that needs to be documented and communicated upon request by the transmission operator or transmission planner. We'll get to the monitoring of real-time AVR, automated voltage, in the GOP section in a few minutes. I'm going to pause there because now we're going to go into the GOP realm just to make sure. Let me look to make sure there's no questions. I think we're good.
No questions in chat yet, but just a reminder for everybody, if you do have questions, go ahead and type those in the chat and we will get to those.
Okay. Now we'll do a similar run through on the GOP side of the house. We are going to talk about one regional variance standard, and that's in BAL 01 TRE. Just note that, while I mentioned in the NERC 101 that for the most part, there is consistency throughout all of North America, especially the United States, in terms of NERC reliability standards. There are some regional variances, so depending on where a facility is located and registered, ensuring that you understand if there are any regional variances that are applicable is important. So we'll cover one example that's applicable in the ERCOT or TRE region, and then we'll jump into communications and operating instructions, which is a very, very important one for GOPs. So BAL 1 is about primary frequency response, and it is really about, again, not similar to modeling, but a little bit different, and making sure that people who need to know understand how the PPC will respond to frequency deviations. I will just mention too, I think we touched on this later, but ERCOT, from a modeling standpoint and from a few other standpoints, is a little different, a little more rigorous in their interconnection requirements. The part 1, part 2, part 3 testing that probably many are familiar with, somewhat all related to this regional variance in BAL 1 as well. Okay, so we're going to start talking about the concept of interpersonal personnel communication and operating instructions. So as I mentioned in NERC 101, a GOP's job is really to not only just monitor and operate the facility, but communicate upstream with transmission operators, balancing authorities, etc. So each GOP needs to have the ability for interpersonal communication with its balancing authority and transmission operator. The balancing authority and transmission operator are the ones defining what that really means. So you have the GOP is going to have a contact matrix, right, for the real-time deaths, the TOP-BA. There's probably an outage management system that you need to submit planned and unplanned outages to. But ensuring the right status updates for the facility are flowing between the generator operator and other reliability entities is super critical. And then there needs to be a plan in place, of course, that if there's a failure in the normal interpersonal communication means, that there is a way, a secondary way, a backup plan, and a call to act, an agreeable action to restore the primary method. So we're going to talk about COM2 now. And COM2 is all about using three-part communication when receiving operating instructions. And so probably let's first focus on the operating instruction definition. This is anytime a real, the BA or the TOP is issuing a real-time instruction command to the GOP to change a status, to move a set point, anything like that. And they're normally calling you because there's either an ongoing reliability issue or a potential impending one. So ensuring that the GOP's personnel receive that instruction correctly is imperative. We see three-part communication probably more times than you may realize. But first, let's define it. So it's that repeat back, right? I think you see it at, Chick-fil-A often, right? They're really good. Starbucks does, and really anyone that needs to ensure they heard your order, right? They'll repeat it back to you. That's the same thing. It's a simple process, but it really helps ensure that there was no miscommunication occurred, that, you didn't mishear what the instruction was. So you repeat back to them. It doesn't necessarily need to be verbatim, but repeat back what you heard as a GOP operator, and whoever's issuing that operating instruction will, confirm or deny. But it's that three parts, right? So acknowledging and confirming, issuing, acknowledging, confirming. So I will just also add that while three-part communication is a good practice, whether you're talking with your spouse or you're, getting an order at Chick-fil-A, you technically do not need to, your operators do not need to utilize three-part communication in every single communication they have with other entities. But it is super important to know when does the conversation change from just one, we're trying to gather basic information, we're just having an informal conversation between two real-time desks to no, we are now issuing an operating instruction in which three-part communication is explicitly required to be used. Because of that, there are training requirements. So all operators, GOP operators, need to be trained on three-part communication. So that is part of the training plan that is explicitly required for GOPs, and we'll talk about that a little bit more later. All right. This one, IRO 1, is related as well, but it's essentially saying if a GOP receives, really, if anyone receives an operating instruction, you have to comply with it, unless you are unable to comply with it. So you can't say, no, I'm not going to move this set point, unless there is a, safety, physical, or other limitation that prevents you from complying with the issued operating instruction. So that's really all IRO 1 says. And then TOP 1 is essentially the same, but now just receiving an operating instruction from the TOP instead of the RC, which was covered in IRO 1. All right, looks like we got it. Yep. And sorry, and then also balancing authority. So punchline being here, again, covered in NERC 101, but the GOP is kind of at the bottom of the food chain, for lack of a better way to phrase it. So whether the TOP, BA, or RC is issuing an operating instruction, again, unless the GOP is unable to comply with that operating instruction, you must comply. All right, data specifications. So we see both IRO, family of standards, and TOP again. These are essentially, again, mirrored, just like we went through with the operating instruction requirements, to enforce a requirement on the generator, operator, and other entity types that they have to meet the requirements for data specifications and data transfer to both the reliability coordinator as well as their associated transmission operator. So these data specifications, are usually all the time publicly available. If you're not sure what they are, you can always reach out and contact your associated TOP and RC. But these are things like, here's an example from LADWP, right? The types of information that they require from the facility, as well as the data transfer type, and seeing LADWPs suggesting requesting ICCP, Intercontrol Center Protocol, communicate or data transfer about the facility status to their systems, again, so they can be monitoring real-time status and make decisions around contingency planning, etc. These things don't change. These requirements do not change all that often, but it is one of those, and the TOP and BA and RC all have a requirement to notify their affected parties when they do change, but it's something that you should proactively ensure you understand, during the interconnection process as well as into commercial operations. Many times these types of requirements are also spelled out in the interconnection agreement. But again, it's good to periodically check to ensure that nothing's changed on the TOP or RC side and or BA side in terms of what data they need and how do they need that data. Again, haircuts a little bit different. So we talked about the different testing requirements. So all of this will come to light during the part 1, part 2, part 3 testing. The only other thing to say is that usually the qualified scheduling coordinator is actually the entity type that is handling the data transfer to the necessary entities. So in ERCOT's region, we call them qualified scheduling coordinators, QUEASIs. In CAISO's region, we call them scheduling coordinators, SCs, so on and so forth. They are market functions. They are not NERC, NERC 101, right? We didn't talk about and define in the NERC functional model what a QSE is or an SC, because they are not NERC registered entities. However, they're supporting a market function, and in the case of the data specification standards we just reviewed, they're typically the ones carrying out that data transfer requirement on a day-to-day basis. There are a lot of additional requirements in ERCOT's nodal protocols and market guides for how qualified scheduling entities receive and transmit the data necessary. And then similarly, again, example in California ISO, hundreds of pages of business practice manuals about what scheduling coordinators need to do in that footprint. I would say, though, a lot of times in the IBR world, while what we're talking about is a GOP requirement, it oftentimes that data doesn't get sent from the control center. Oftentimes we're gathering that data locally at the generating facility and directly sending it to the SC or qualified scheduling entity for the facility, and then they're passing that along to the TOP, et cetera. So usually that data does not actually flow through the associated GOP control center. All right, we already touched on one training aspect that's embedded in COM2 for three-part communication, but then there are two separate personnel standards, PR5 and PR6, that require training for GOPs. So PR5 is applicable in this 4.15 section. It's another one that's not necessarily applicable to all GOPs, but it winds up being applicable to most based on that definition you see on the screen. And it's any personnel who receive direction from any of the other entities we've been talking about all along. And so, if you're working in a GOP control center, you have the potential to receive those types of operating instructions from a TOP, BA, et cetera. Therefore, all GOP operators, need to be trained under the PR5 requirements. One thing I'll probably just touch on is they want a systematic approach to training, and that usually results in like an ADDIE framework, so that you have to have a rigorous enough program in place to track and evaluate competencies and skill sets and performance of the operator over time. And ideally, in a somewhat mature program, you're tailoring the training requirements on a rolling basis, based on those evaluations that occur for each of your operators. This is one of the many requirements that first training needs to happen, before registration of the control center, and then be maintained in an ongoing fashion thereafter. PR6 is focused, while PR5 is kind of just overarching, right? Have a competency and systematic training approach for any personnel who may receive dispatch or operating instructions. PR6 is focused in on understanding the protection system elements at a facility, and especially if there's any remedial action schemes or SPS, special protection systems, that are associated with the facility. So this, when doing PR6 training for a GOP, this usually involves on a facility by facility basis. So generator owner site by generator owner site, walking through the 3-line diagrams, looking at the protection schemes, understanding, they don't need to be a protection system expert by the end of this training, but they need to understand the basics and how these elements are coordinated and work in tandem. And then they need to be trained on that. Again, this is another thing that should be done prior to registration and then maintained that thereafter. This requirement doesn't have a recurring training requirement for each operator. However, what does need to be tracked at the very minimum, always a good idea to do refresher training for all, but at the very minimum, as you're bringing on new operators into the GOP environment, both on the PR6 and PR5 side and COM2 for 3-part training, you need to make sure that's part of their onboarding plan before they step into, the formal GOP operator role. And we certainly don't have enough time to get into all the fun protection system, engineering details, but figured I'd at least provide a quick cheat sheet here on the ANSI standard device numbers for protection systems. So if you ever looked at a 3-line or seen blue boxes in the field, those numbers aren't completely random. They mean something. They are defined. They are standard. So that's always a reference material and something that should be part of that PR6 training for your operators. Okay, now here's the VAR2 as it relates to GOP that I jumped the gun on earlier, and saying that it's one of the most, if not the most, typically violated GOP requirement. It's because upon a change in status of automatic AVR, automatic voltage control mode, you have GOP has a requirement to notify the TOP within 30 minutes. So one, the time horizon's tight, 30 minutes, and two, oftentimes, especially in the IVR world, maybe the original SCADA integrator who developed the HMI wasn't really aware of R2 and the criticality of AVR. So it's not really a status or a set point that is visualized in the HMI to operators and highlighted as much as it really should be. Another issue we've seen, unfortunately, time and time again is, as a facility is being commissioned, AVR's left off, right? Or somebody's going in to do upgrade maintenance to the plant SCADA system, power plant controller, inadvertently changes the AVR status, and that is missed by the GOP and not communicated to the TOP. So then we move down, then you're starting to move down that self-reporting process that we spoke about in NERC 101. So make sure that when you're working with SCADA integrators and asset owners, if you're the GOP, that you have good visibility and understanding of AVR and have alarming set up for if that status ever changes, and understand how and who do you notify from a TOP standpoint if that status changes within 30 minutes. We won't go into all these details, but one other aspect of R2, because it obviously plays into voltage schedules, is that you need to meet the voltage schedule and reactive power schedule provided by the TOP. So by default, you're normally in automatic voltage control mode, but there are changes or situations that arise where maybe you're instructed to go out of AVR, etc. Again, just like an operating instruction, that is something the GOP must comply with unless there is a technical or safety type limitation for which you cannot comply. All right, here's where the scary 30 minutes, notifying within 30 minutes of change comes into play for R3. And then same thing if there's a change in reactive power capability as well. Although currently there is a carve out for our IBR friends on R4. We will see if that change is as the heightened focus on IBRs continues and standards evolve. So in summary, again, just really focusing on this, just given the number of violations we've seen over the years, make sure you know what your starting status is from a power plant master controller standpoint is. How are you monitoring it? How are you alarming on it? And who and how are you communicating any changes in status that may occur? And similarly, if you cannot maintain the issued voltage schedule from the TOP, how do you identify that you're not maintaining it? What's the process for seeing if you can make changes to get back in compliance with the issued voltage schedule? And who are you notifying if that's not possible to receive operating instructions on next step? All right, now we're going to do a little bit of a deeper dive just into GOP program development, implementation. We'll start with a very high level timeline. starting with, this would be for like a new GOP control center build. I would say though that 8 months is definitely aggressive, to put it lightly, for a new control center build. Normally, we're looking at about 12 to 18 months to stand up a new GOP control center. And that green line there for construction, if you are physically building a new facility, of course, that's the big variable: construction delays, et cetera, that must be accounted for if you are considering standing up a new control center. But lots that goes into it, physical design, everything from ergonomics of where the operator desks are going to be, what's the video wall, what screens and situational awareness tools you're going to provide them, where do physical access controls go for the control center, as well as associated IT, OT equipment that is required to run the control center. What does that network look like? All of that. And then, of course, the actual NERC program development. So developing all the policies and procedures, meeting the requirements we just spoke about, plus more that we didn't have time to get into. The training that needs to occur for operators prior to registration, all of that. So here, kind of an unpacking of that a little bit. And again, just to reiterate, we just on this session are talking about the O&P or 693 aspects of a GOP program, but NGO program, but there's also the critical infrastructure protection SIP requirements that we'll go through later this afternoon. As we mentioned, that there's some requirements in GO and GOP that are technically applicable to that entity type, that registration type, but they have more refined applicability for certain characteristics of the facility, et cetera. So one thing as part of your compliance program you must do is develop any attestations, right? So we talked about FACT-3 vegetation management earlier. If you don't have more than a mile of gen-tie, great, quick attestation with a little supporting evidence from the LGIA or something showing the length of the gen-tie. Good, now we're done. That's all you need to do. But there are usually going to be a handful of attestations that need to be developed as part of the initial program stand-up. And then we talked about the internal compliance program, or ICP, in the NERC 101 section. That's something that also should be, doesn't absolutely need to be, because it's not a mandatory reliability standard, but strongly recommended. That should be put in place prior to registration as well. So again, just kind of breaking this out a little bit more, getting your ICP in place, setting the culture of compliance within your organization, a kind of umbrella policy over all the other different policies and procedures you're going to have to meet explicit reliability standards, identifying where there are specific site operating procedures, right? Because a lot in the GOP NERC program is, it's associated with the control center. It's overarching, right? So, you have site A versus site B. A lot of your GOP program doesn't change as you bring on site C. But as we talked about in PDR6 and a few other examples, there are facility specifics that need to be brought into the overarching GOP program. So ensuring you have an understanding of day one facilities and where there are, deviation, there needs to be specific procedures and guidance for that facility, and then also in an ongoing capacity as new facilities are brought into the control center. We'll get into this more, but you also have some things you need to do prior to registration on the SIP side of the house. One of which is conducting the cybersecurity incident response tabletop exercise. So it's kind of like training, but a little bit different. Then we already talked about the 3-part COM2 training, PRC and PER training. But then there's best practice training. So we get this question a lot, and for new control centers, GOPs being established, and they're like, well, the do I need to get certified? Does the control center need to get certified itself? Do my operators need to get certified? And if you were on the previous session, I did mention that one of the things NERC is responsible for is certifications. However, for GOPs, there is no certification process for the control center. That only applies to TOP control centers and higher. And then same thing on the personnel certifications. There is no NERC GOP, generator operator certification. However, a lot of people find value in having their GOP operators take the NERC transmission operator certification or even balancing authority operator certification, because it's really important to know not just what am I doing, myoptically speaking, for the facilities I'm monitoring and operating, but how does it affect others, right? Because you have a lot of requirements in coordinating, communicating with those neighboring reliability entities and the TOPs, BAs, et cetera. So it's usually a good idea to have, at least one or two of your senior operators, certified in transmission operators or balancing authority operations, even though that's not explicitly required. And that's a very long-winded way of saying that while you only have to do training to be compliant in a few specific areas for GOPs, there's a lot of best practice training that should go into play, not only to maintain reliability of the bulk electric system, which is the core goal of all of this, but also to best support the generator owner and your customer in ensuring that their facility is available as much as possible and producing as many electrons, aka making as much money as possible. So a lot of best practice training we always recommend, even though it's not explicitly required by the GOP standards.
Hey, John, we have a couple questions that came in. First up, will slides be available? And the answer to that is yes, we will make the slides available along with the live recording. The second question, John, is NERC staffed appropriately to facilitate and approve registration? And the follow-up to that is there a risk that NERC could be overwhelmed with more IPPs or generating resources coming online? So 8-month timeline becomes a year plus.
Yes and yes. So I guess one thing I'll just point out, even though we call it, you're registering with NERC because at the end of the day, you get a NCR number. However, you're actually submitting that registration to a regional entity. So if you have a facility in California where we're sitting, that the initial registration request actually goes to WEC, not to NERC directly. Nonetheless, yeah, as I touched on earlier, we're already at a 6 to 9 year audit schedule for GOs and GOPs because of the existing volume versus the existing supply of auditors and such. So yeah, that problem's not getting any better. I was at the NERC's GridSecurity conference last week, and a bunch of auditors from different regions are there, and it was a topic of discussion, at least at the lunch tables and in the halls. I didn't see anyone publicly address it on stage, for better or for worse, but every region is really backlogged in enforcement actions, from self-reports and other things, and also just backlogged in processing and dealing with the growing number of registered entities. And on top of that we're about to have a wave of existing generators that are currently unregistered be forced to register by 2026. And yeah, it's a real problem. And I don't know what the answer is. I mean, the simple but hard answer is they need more staff across all the regions, but whether or not that happens, to be determined. So we talked about the systematic approach to training. We don't need to harp on that anymore. Another thing that is not required, but definitely a recommended best practice, especially if you have a new control center, maybe not a lot of experienced control center operators, is really having someone who's qualified to do some on-site control room observations, right? Somebody who's been in the utility industry for a while, who has been an operator in different capacities, just being able to sit in within the control center, hear the conversations going on between operators, see the data and the screens they're looking at, and just share lessons learned and experiences so that younger control room operators can hopefully learn some lessons the easy way instead of the hard way from more experienced folks. And then last and certainly not least is standing up and deciding how you're going to manage evidence long term. So with all of these requirements, some of the things we explicitly talked about, like doing training before registration occurs, that's really there to set your day one compliance posture, right? So you want to make sure prior to going through the registration process that your ducks are in a row. And that means generating evidence for all applicable requirements. Depending on the requirement type, that may just mean having the program in place. That may mean having that policy program in place and training on it. In other requirements, that may mean all of that plus actual technical evidence to support the implementation of that policy or procedure. But making sure that you can demonstrate compliance on day one is super important, and then have the right plan and program to maintain evidence and organization, again, over that 6 to 9 year cycle for the first time you're going to be audited. And that's one thing we always harp on too, especially with our inverter-based clients, is that long audit schedule, plus the fact that for better or for worse, it seems like the average tenure of an employee within the renewable industry is 1.5 to 2 years before they switch companies within the industry. It is super imperative to make sure that the documentation, the associated evidence, can stand on its own and tell the story on its own. Because that's one thing the traditional IOUs, vertically integrated utilities, have going for them is, they have these programs, but if there's an evidence gap or documentation doesn't tell that story from 6 years ago that comes up during audit, there's usually Bob down the hall that's been there for 30 years that you can tap on for an audit interview and kind of piece together what actually happened if documentation sparse. But in the renewable sector, we all have to work and assume that is not going to be the case, that none of us involved with the project at registration are going to be there by the time the first audit occurs 6 to 9 years from now. So again, just making sure that between the program, policies, procedures, and supporting evidence, you have enough documentation and enough structure to tell that story without a human involved. All right, and then just real quick on what does the registration process actually look like? Another area in which for clients who are new to the NERC world, usually there's a lot of concern and like, oh, this is going to be a big deal. The actual registration process is the quote unquote easy part, right? It's all that preparation we talked about, getting the program in place, having day one evidence. That is the heavy lift. The actual registration process isn't all that painful, but I think alluding to the question that was just asked is one of the challenges in registration is the timeline. So you submit your registration. All the regions currently are asking for 60-day notice, aka submitting the initial registration request 60 days before expected commercial operations, in which registration is required, so that there's enough time to go back and forth on any missing data, right? And so that they have enough time to process it. But one of the challenging parts about registration is it's kind of a crapshoot black hole that from the time you actually submit the registration request to the time that you truly get your NCR number back and issued, and aka your audit period starts, it varies, right? So you need to be ready to demonstrate compliance, ideally when you submit the initial registration request, just because there is some variability in that timeline. But long story short, all the regions now are finally aligned and asking for the registration request to be submitted 60 days before COD. You'll have to establish, the primary and alternative points of contact for compliance with NERC in the region. You're going to get set up in a few of the few portals with NERC, and that's where notifications will happen. Things like NERC alerts, which we haven't talked about yet, where self-certification and other processes occur. So there's a little bit of that, set up accounts, et cetera, that needs to occur. The only other thing I'll talk about from a registration standpoint is that the owner of the generator, the GO, or soon to be GO, whose project is maybe triggering registration for the GOP, the GO is kind of first to go, right? So the GO is actually initiating the registration request, but as part of that request, they have to formally denote who their associated GOP is going to be. So those two things need to happen in parallel or together. And so the GO and GOP need to be in coordination about that.